Have you ever wondered how companies like Amazon, Flipkart, Swiggy, PhonePe, Netflix, or even your banking app are built? Every day, millions of people search for products, make payments, book tickets, transfer money, and stream videos without thinking about what happens behind the scenes. But have you ever asked yourself, who builds these applications? Which programming language do companies use? Why is Java still one of the most in-demand technologies after nearly 30 years? And if you're planning to become a software engineer in 2026, is Java full stack still a good career choice? In this video, I'm going to answer all of these questions. By the end of this video, you'll understand what Java full stack development actually is, how enterprise software is built, which technologies companies use, why Java is trusted by enterprise companies, career opportunities and salary growth, a practical roadmap to become a Java full stack developer. Let's begin. Let's start with something simple. Imagine you're ordering a mobile phone from Amazon. You open the app, you search for the product, you add it to your cart, you make the payment, the warehouse receives your order, the seller gets notified, the inventory gets updated, the delivery partner receives the pickup request. You receive an email and an SMS confirmation. Now think about this. Is all of this handled by a single program? No. Behind this one order, there are dozens of independent systems working together. The search system, the authentication system, the payment system, the inventory system, the delivery system, the notification system, the analytics system. Applications like these are called enterprise applications. These are large-scale software systems designed to serve thousands or even millions of users simultaneously while remaining secure, reliable, and highly available. The same concept applies to banking apps, hospital management systems, airline reservation systems, insurance portals, ERP software, CRM platforms, and government applications. This is where Java has been one of the industry's strongest technologies for decades. Now let's understand how a typical application works. Suppose you click the login button on an e-commerce website. The first thing you see is the user interface. This is called the front end. Its responsibility is to display information and collect user input. Technologies commonly used here include HTML, CSS, JavaScript, and frameworks like React. Once you click login, your credentials are sent to the backend. The backend is the brain of the application. This is where Java and Spring Boot are commonly used. The backend verifies your username and password, applies business rules, and communicates with the database. The database stores information such as user accounts, products, orders, payments, and transaction history. Once the information is verified, the backend sends a secure response back to the front end and your dashboard appears. In large organizations, this process involves APIs, authentication, databases, caching, messaging systems, cloud infrastructure, and monitoring tools, all working together seamlessly. This complete ecosystem is what we refer to as a full-stack application. Many students ask, why should I learn Java when there are so many programming languages available? The answer lies in enterprise requirements. Large organizations don't choose technologies based on trends. They choose technologies based on reliability, scalability, security, and long-term maintainability. Java has built a strong reputation in all of these areas. That is why Java continues to be widely used in banking, insurance, healthcare, e-commerce, logistics, and large enterprise systems. Another major advantage is the Spring ecosystem. Spring Boot enables developers to build secure, scalable, and production-ready applications efficiently. Combined with modern front-end technologies like React, Java becomes a complete full-stack solution. Today, AI tools also make Java development more productive by assisting with code generation, testing, documentation, debugging, and code reviews. The role of the developer is evolving, not disappearing. Let's look at the technologies that a modern Java full-stack developer typically works with. First, programming language, Java. Next, backend framework, Spring Boot. Then database, MySQL or PostgreSQL. Moving on to front-end, React. For version control, Git and GitHub. For build tools, Maven or Gradle. When it comes to API development, REST APIs. For authentication, Spring Security and JWT. Next, microservices, breaking large applications into smaller, independently deployable services. For messaging, Kafka or RabbitMQ for asynchronous communication. To improve performance, caching, Redis for faster performance. For cloud, AWS, Azure, or Google Cloud. For containerization, Docker, and for container orchestration, Kubernetes. To automate deployment, CI or CD, Jenkins or GitHub Actions. Finally, AI tools, ChatGPT, GitHub Copilot, Cursor, Claude, and Gemini to improve developer productivity. Remember, you don't learn all of these on day one. You learn them step by step as you progress. So, what does the journey look like? Start by learning programming fundamentals and core Java, then move to object-oriented programming, collections, exception handling, multi-threading, and modern Java features. Next, learn SQL and databases. After that, move into Spring Framework, Spring Boot, REST APIs, and Spring Security. Once your backend skills are solid, learn React to build modern user interfaces. Finally, expand into microservices, Docker, Kubernetes, cloud, and AI-assisted development. Throughout this journey, build real-world projects. Projects are what demonstrate your practical skills during interviews. The more closely your projects resemble enterprise applications, the stronger your profile becomes. As you gain experience, your responsibilities grow, from writing features to designing systems, mentoring developers, and making architectural decisions. That's why Java remains a strong long-term career option. Java full-stack development is much more than learning a programming language. It is about understanding how modern software systems are designed, developed, deployed, and maintained. If your goal is to work on enterprise applications used by millions of users, Java full stack continues to be one of the strongest career paths. In the coming videos, we'll start from the basics and gradually build the skills required to become an industry-ready Java full stack developer. Let's begin the journey toward becoming a professional Java full stack developer.